Hello, welcome back to Mrs. Swords' YouTube channel. Today we are starting chapter 10, which is trigonometry. Now, this word might be a very foreign word to you, but all that it means is it's the study of the angle measures of triangles. So we're going to learn about some functions that relate the angles or the sides of triangles, specifically right triangles. So first thing that I want to talk about is when you are given a right triangle like this and we need to use trigonometry, you will be given a reference angle. Your reference angle will always be one of the angles that's not the right angle. So you're not going to use the right angle as your reference angle, and you'll see why in a second. So in this first triangle, and we usually mark them with a Greek letter theta. So theta looks like that. It's kind of just like a circle with like a little extra loop there. I like to mark my reference angle that way as well, just so it really stands out which angle is my reference angle. These functions that we will talk about in a second are ratios of the lengths of sides of this triangle. So we need to label the sides so we know which side we're referencing. So when you're given a right triangle, there's two legs and then the hypotenuse, right? So the hypotenuse is the first side that I'm going to label. Remember, that's always across from our right angle. Now, the other two angles we need to label in reference to our reference angle. So there's two ways that we're going to label these. One of these sides is opposite of theta, and one of them is adjacent. Remember, opposite means across from. So if I take my pencil and I draw an arrow from my reference angle, the side that I hit is my opposite side. And then the other side that's left is adjacent. Remember, adjacent means next to. So this angle is, or this side is next to my reference angle, and it's not the hypotenuse, because this is also adjacent, but more specifically, it's the hypotenuse. So we can have our reference angle here, or this bottom angle could be our reference angle. So we want to label these sides again. The hypotenuse doesn't change, right? That's still always across from the right angle. However, adjacent and opposite change now. Now that this is my reference angle, if I draw my arrow, the side that I hit is here. So here is our opposite side this time. And then our adjacent side is actually this bottom one. So when you're trying to figure out these ratios that I'm going to talk about in a second, you want to make sure you label all three of your sides. I know some of us don't like to write a lot, so we could just do H, A, and O, just so you know which side you're dealing with. All right. Down in this table here, we have, let me make this a little straight here. There we go. We have our three trigonometry functions. So these are sine, cosine, and tangent. Once you get to pre-calc and calc, you will deal with what these functions are specifically, properties, things like that. But for the purposes of our class, all we need to know is that those are functions that relate the sides of right triangles. So we don't need to know any really more specifics about those, other than that though they are functions that relate the sides of right triangles. Okay. Also, this theta, remember that is our reference angle. So in this diagram it's labeled X. I'm just going to label theta there. So if I want to know what the sine of theta is, remember that's just a function, right? So really this is just a number. So sine of some angle, in this case it's here, that's the angle measure. We don't know what the angle measure is, so we just label it theta. So sine of theta is our opposite side over our hypotenuse. So let's give this triangle some side lengths. Let's say the hypotenuse is 5, 4, and 3. So The sine of theta would be opposite, which is 4, over hypotenuse, which is 5. Now, you can just keep it as 4/5. When you get to IXL, and I think maybe Delta Math as well, it will ask you to round this to the nearest hundredth. So you just need to put it in your calculator and get a decimal. Next, we have cosine of theta. Remember, this is just a number, so the cosine of theta is the adjacent side over the hypotenuse side. Well, let's look at our triangle. Adjacent side is 3, hypotenuse is 5. So the cosine of theta is equal to 3/5. And lastly, we have tangent. So the tangent of theta is our opposite side, which is 4, over our adjacent side, which is 3. So sine, cosine, and tangent are just functions, and functions that relate the sides of right triangles. That's all we need to know for the purposes of our class. So this seems like a lot to remember, right? There's a nice little word that's kind of like an acronym that we can use to remember these ratios. It is so S-O-H, ka, and toa. SOHCAHTOA. So you might hear me say that a lot in this chapter. SOHCAHTOA. So what that means is the sine, so means the sine of theta, that's the S, is equal to opposite over hypotenuse, OH. Ka means cosine of theta equals adjacent over hypotenuse. And then, of course, TOA is just tangent of theta is opposite over adjacent. So this SOHCAHTOA helps you remember what these ratios are. So whenever you're working on IXL, you want SOHCAHTOA. Whenever you're working on homework, classwork, a test, a quiz, you want to write SOHCAHTOA at the top. And I will show you my paper. Look at my key. I still write SOHCAHTOA at the top when I'm making the worksheet. Even though I'm a teacher, I need to write it up there so I remember what those ratios are. It's a really good resource. So SOHCAHTOA is our magic word there. All right. Next thing I want to do is show you how to get these in your calculator. So I'm going to bring this down a little bit closer to my calculator. Okay, so the first one that we're going to look at is the cosine of 17. Now, in this class, I know it's hard to see the paper now, but it's easier to see the calculator. I'll switch back when I go back. But the cosine of 17. This means the cosine of 17 degrees. This is saying that my reference angle is 17 degrees. We need to make sure that our calculator is in degree mode. So, up at the top here, you've got second, and then right next to it is mode. Go ahead and click on mode. It brings up a bunch of different options. This third row here says radian and degree. We want degree to be highlighted. So some of your calculators might look like this with radian highlighted. Radians is just another way to measure angles. You will use that in pre-calc. We don't use radians in our class. So we want to make sure that we're measuring our angles in degrees. So we go over degree, hit enter, and degree should be highlighted. That's what you want. Once you click on degree, it will save. So then you can hit second and mode. That quits out of there. If you ever get stuck in anything and need to quit, you can just hit second quit. So now we're in degree mode. Now we can figure out what the cosine of 17 is. Let me turn down my brightness a tad. Okay. So cosine of 17. If we look on our calculator, here's our numbers. 2 rows above my numbers, I have sine, cosine, and tangent. Those are the trig functions that we are going to use in this class. So to figure out the cosine of 17 degrees, I am going to hit cosine. Go out a little bit so we can see it all. Okay, cosine. And then on your calculator, it'll pop up cosine and then parentheses. And we want 17 degrees, so we type 17, close our parentheses, hit enter, 0.96. Let's round to the nearest hundredth. So the cosine of 17 is 0.96. All right, next we've got tangent of 81. So we want tangent 81, close our parentheses, hit enter, 6.31. And lastly, sine of 30. So sine right here, 30 degrees, close our parentheses, 0.5. If you did not get these answers, I would go back into your mode, make sure you're in degree mode. Let me show you what happens if I'm in radian mode. So if I'm accidentally in radian mode and I type in the sine of 30, way different answer, right? So it is important that you are in degree mode. So mode, degree. All right. So let's look at an actual problem. I'm going to come back to the IXL. If you flip in your packet until you see a little number 1 at the bottom right corner, I put a few packets together so my numbering's a little funky. But at the top it says Trig Basics. Okay, so I'm going to show you a few of these. So we want the tangent of C. First of all, we want to write our word at the top. SOHCAHTOA. That's how we know what our ratios are, right? So tangent of C. That means C is our reference angle. I'm going to mark C. Then I need to label my opposite, adjacent, and hypotenuse. Well, hypotenuse is the easiest one, right? It's across from our right angle. So I'm just going to put an H. Then we need opposite. Opposite means it's across from our reference angle. So that means 30 is our opposite. And then the side that's left is our adjacent, next to our angle. Okay, cool. So we need tangent of C. So tangent of C equals, we look at our word up here, opposite over adjacent. So opposite is 30. Adjacent is 16. And then you want to make sure you reduce your fractions. So we can reduce this to 15 over 8. So that means the tangent of C is 15 over 8. On this worksheet, I'm fine if you keep them in fraction form. I would actually prefer that you keep them as a fraction here. All right, let's do one more. So sine of Z, that's telling us Z is our reference angle. So I'm going to mark that. All right, let's mark our sides. Hypotenuse, opposite, adjacent. So sine of Z equals, we look at our word, opposite over hypotenuse. So opposite is 16, hypotenuse 34. There's a really easy way to reduce fractions in your calculator. I'll show you. So we type in our calculator, our fraction, 16 over 34. And then if you hit math and you hit frac and you hit enter, it's going to reduce the fraction for you. Now, if you have the smaller scientific calculator, you might have to play around with it. There is a fraction to decimal button that you might be able to use, but if you have a graphing calculator, it's a really easy way to reduce fractions. So our answer is 8 over 17. Okay, now I want to go back and show you an example from IXL. So the first IXL on your list is going to be Algebra 1, HH1. Here's an example. So we have this triangle here. It says find the tangent of angle U to the nearest hundredth. So nearest hundredth means I'm not going to keep it in fraction form, right? I need to put in my calculator and get a decimal. So tangent of U, so that means that's my reference angle. So let's label our sides. We've got hypotenuse, we've got opposite, and then adjacent is up here. So we look at our magic word. Tangent is opposite over adjacent. Do we know the adjacent side? No. Could we find the adjacent side using some theorem that's very important? Yes. Pythagorean theorem, right? So we could say 12 squared plus, I'm just going to use x squared to find ut, equals 13 squared. 144 plus x squared equals 169. Take 169 minus 144, you get 25. So x squared equals 25. Square root of both sides, you get x equals 5. So that means our adjacent side there, ut is 5. Now we can find the tangent. So tangent of u equals opposite over adjacent. So opposite is 13. Adjacent is 5. And it says to the nearest hundredth. So we just have to turn that into a decimal. Remember, fractions just mean divide. 13 divided by 5. So your answer would be 2.6. So that's what you would put in for your final answer in an IXL. All right, I know this video was a little longer, but I appreciate you sticking with me. See you next time.